So this is the concept of the day is momentum, okay? And just be careful with these things. What you really, really don't want to do with these air track gliders is drop them, okay? Because if you drop them, the little corners get a ding on them. And then instead of floating on a film of air, okay, they drag on the air track, or they get bent or something like that. So just be really, really careful that you don't drop them. Also, if you're pushing them around, you don't want them to go clank. If they're making a clanking sound, whatever it is you're doing is a little bit too hard. Back off of that, right? Okay. So obviously, this glider's got more mass than this glider, and if they hit head-on in a collision, this is why football players are big, right? If they've got more or less the same velocity, after the collision, they go that way, right?
Yeah.
Right, and this makes sense because a larger glider has more momentum and has more inertia, right? And so if they're going the same speed, everybody knows, this is common sense, right? Everybody knows that it's going to, when they collide, they're going to end up going the way the big person was going. Yeah?
Yeah.
Okay. Now, is it possible to have these guys hit head on and stop dead? Is that possible? Yeah, if everything's perfect. So what would we have to do?
Equal out. You have to make the smaller one go faster.
Smaller one's got to go faster to make up for its lack of mass. But if it was going faster, it's possible that, let me just show you, right? It's like let's get this guy coming along. Big guy coming along, right? This guy's got to go a little bit faster, doesn't it? Oh, it didn't stick. Oh! Right? This guy's got to go a little bit faster, doesn't it? Let's see if they stick. Ooh, that almost stopped dead. That's like the best I've ever done, right?
Wow.
Okay, so they could hit head on like this, right? Okay, and if the little one's going faster, then it could stick and head on. They could stick and stop dead. I can't talk anymore. Okay, where are we? Okay, so right now it's not energy. It turns out that you need to actually minimize there. There's something called momentum, and it's very simple. If this has half the mass of this one, then it has to go twice the speed.
Yeah.
Okay, it's just a simple proportion like that, and that's a wonderful thing. So momentum is very simple, and the formula for momentum is just mass times velocity. Okay. So momentum is mass times velocity, and this is like, it's all lowercase letters. Why we use P, notice it's a lowercase p, right? Why we use P, I really don't know. Duggan says it's in your book, though. Okay? But anyway, there it is. It's kind of like in physics, there are 26 letters in the alphabet, 52 if you include capitals as opposed to lowercase. And we use the same 8 over and over and over again. So we use P for power, P for pressure, P for momentum. Why not, right? The real reason is this, is that P's, it's a silent P, really. Originally it was spelled, right? Just like pneumatic, right? And you just don't say the P. We just don't put the P's anymore, right? It's just like a B, right? That's not the real reason. I really don't know the real reason. I just made that up because I thought that was funny. Here's our formula for this, is that it's mass times velocity. This is just the mass of the object in kilograms, right? This is velocity, meters per second. And then this has the units of nothing other than kilograms, meters per second. And I used to, spend a long time trying to explain, that it was like a Sahibi of momentum or something like that, right? And some kid would be like, "That's my last name," and then they realized that it probably wasn't a Sahibi, and that I was like making fun of them, and and then they'd have a better than average moment, and then it'd be like a lower than average moment for a long time. Yeah. Kilograms, meters per second is what it is. No, it's just that's what the units are, right? Okay, so there's our momentum. They're all lowercase, and if you want to, you can make a triangle of power like this. P is mv. If that helps, does that help? That kind of helps. Doesn't that help? That helps a little bit, right? And there's no other thing for it, right? So if some object, if a 5 kilogram object is going 2 meters per second, right? Its momentum is 10 kilogram meters per second. Yeah? That's pretty hard. There it is. Blah, blah, blah. We already talked about stopping dead. They stopped dead. We already did 300 gram swallow. By the way, swallows have a mass of about 23 grams. So this is like a swallow that has been eating too many fats and sweets, right? An overweight swallow. Why don't you see those? Times the mass of an ordinary swallow. That's like you weighing 1,000 pounds. All right. Let's see some of these.